Hello guys, in this episode I will go back to the microchip microcontroller, and this microcontroller is PIC18F4550, this one. And I will demonstrate the implementations of the USB bootloaders on this device. And here is what the hardware and software that I need to do these things. First, this board, same as mentioned previously, except I added a mini USB socket here, and of course this key switch and the LED modulars. And in the boards I inserted the microcontroller here, and also attach a capacitor here. And you have to notice there is key switch here, and in this circuit diagram I will present what is this. Here is VUSB, and this a 220 values ceramic capacitor is attached, and this to the ground. And these two pins, 23 and 24, is the pins for the USB port. And another important thing is this number 13/7 pin RB4, and it's usually used for attaching and key switch here for selection of the USB mode. And here I attach a pull-up resistor 10 kilo, and here is ground. No much special here. And in the demonstration board I attached the wire here to the key switch, and also wire to the LEDs. This I will not describe them, and it's just an arbitrary choose which pin go to which area. And one thing is I use a testing LED here. You can see this LED it attached to the number 2 RA1, sorry, RA0. And also a lead wire here. This also a for testing. It attached to interrupt 0. This is the pin number let's see, it's INT0 here, number 13C. And now we test it by attach it into the 0 volt and see if this LED flipped or flash, and it demonstrates the interrupt subroutine is running. And of course I need to have a IDE. This is, I use the here MPEG IDE 4.01 MP-Labs X IDE, and this IDE I use XC8 compiler. You can see here, this one, use this compiler. But in this computer side, the trial mode, for the trial mode of the pole the one for the pole is expired. It can be used for only 16 days. After it, the pole modus will be expired and it will switch back to the this free mode. And in the free mode, the code will not be optimized to a small size, and you will find tons of the code will be made. And this is the drawbacks of using microchip controller. And in doing the USB installations, or to do these functions, many people also know that it's suggested to use the pole function compilers, because the codes for the bootloader, USB bootloader, will exceed 1000 in the memories. And that means if you use the compiler pole compilers, professionals compilers, the codes will be shrinked to under 1000, and it can be fit into the memory address. But in these computers, it's expired, so I need to use the free mode. But anyways, I can do it as well, and I will show how this was done. And compiler and the IDE, then I need to explain some software. And here I need to have the non-drader. Here is my pencil. This is the non-traders 18 non-traders bootloader program, and this is my main program. And where I get this bootloader programs, it was in And here, let me go back a little bit. Here I install the MPLAB XC and also XC compiler in this directory. This can be downloaded from this website. And another directory I need to install is this MLA, and in this website, and in this directory you go to the USB folder, and here go to this bootloader firmware, and here is the 18 non-dreaded. This is the bootloader program, and also one other program. Here I show here. This is bootloader. What is this? When you install the bootloader into the MCU, you will no longer need to this PIC18F4550 to program it. Instead, you plug in the USB and this computer program. This program, the USB bootloader program installed into this IC, and after attaching the USB cord into the connect to the computer and open this PC program here, then it will detect, and we need to insert the hex file there and use this program to record the code into the microcontroller. And this program, where I can get this program, is also in the MLA folder, and under the bootloader here is utility bin, and here I choose Win, and here this is the bootloader program, and I off this first, and I'll click this, and this will appear. And now is device not detect because it's not connect. So you will find it's quite complicated for PIC microcontroller. That a lot of stuff need to be set off, need to be downloaded to do so. And I try to figure out what this, where I can find this bootloader program. I spent a lot of times. So nowadays, many people, especially the hobbyists, don't use microcontroller. Anyway, I continue to explain it. And here, two programs. Here, one is bootloader, one is the main program. First, I explain my main program. Main program is a simple one, just testing the I/O function and by the key switch and the LED, which key push on which LED on, and also the external interrupt function. Here, every time external interrupt trigger, the LED, it will do this subroutine, and the LED in the pin RA0 will be flash, will be flipped. And another program is this non-dreaded bootloader program. The detail is complicated, and except for those who really want the functioning and how to program make the code for the USB. Otherwise at least I don't need to understand fully what the code inside. I just use it, and then this main program in PIC, there is a lot of config setting here, and here is another one is the PDF file. Here is the PDF file for the 4550 spec. One important thing in implementations of the USB functions is to understanding the oscillator details of this model, this microcontroller model. Here, go back to my board. Previously I mentioned this. I have the sockets for the oscillator. Here I inserted 20 megahertz into it, and this so here is primary oscillator, and here attach 20 megahertz here, and there is a PLL functions in the oscillator, and you need to get 4 megahertz here in order to compile with the PLL here. So how to get 4 megahertz here? In here I attach 4 megahertz, not 20, 4 megahertz. How can I get 4 megahertz here? I just set to the P. This is P scalar. Yes, P scalar. I just set to 1, and this here will, after PLL, it will go to 19.6 megahertz, and divide by 2, it will go to 14.8 megahertz. This will fit with the spec for the frequency of the use of the USB usage. So this will 14.8 megahertz, and this need also to be set on the config bit, and here is for oscillator of this tab. So for my oscillator here, refer to the main program, I use PLLHS tab oscillator. So in here, actually I will fit with HS, and this 4 megahertz in here I choose. Actually, it's not quite it's not limited for my selection. I just choose 4, and another one is 6. Go back to here, I choose divide by 4, so it will here 1 megahertz, and here I choose 6. This is 19.6 divided by 6. It will 16 megahertz here, and the rest is for the external oscillator, and you don't need to go into detail here. So go back to config bits here. This divided by 2 because 19.6 megahertz divided by 2 is 14.8 megahertz for USB use. No very special others. So once this config bit is set up for this main program, you need to copy this out or to remember all the setting here, and then I go to this bootloader program and go to the source file and the main, and now this is the main for the bootloader here. This one is main, and go to the config bit here. All these settings should be exactly the same as the previous one that is on the main program. Otherwise, after programming into the microcontroller, it won't work. And another important things to be mentioned is the here bootloader. I click the properties. This model number and go to its compiler. You see here there is optimization. So operation mode, if you have purchased the PO compiler, you have to choose PO. But if you are using now, it show here PO, but actually my computer is running the child license is free license, but even I choose here PO, after compilers the code is still very large, is in free mode, so it don't represent anything. Anyway, my computer is running in the free mode. And another important thing is go to linker here, the memory mode here, the ROM range. This is the programmed area, address area for the bootloaders, and here it will program into the default address except this range. I need to explain clearly here. The minus sign is the meaning of exception. Exception this address. The bootloader will be programmed in the first address area, except from 1400 to, and So the bootloader can have the address from 0 to 1300FF address area for it. And if you use the PIC18F4550 compiler, you can use the less address area here. You can use 1000, but if you haven't the PIC compiler and you use 100 the number in address, then the code will not be fit. And here I will show the code for the bootloader. And another area is this additional option. Here you need to, there is nothing here, nothing need to set here. And then click to the main program here, and also properties. And of course this compiler, if you have the PIC compiler, you need to choose PIC compiler, and then the linker, and go to the memory mode. Here for the main program, the program will be resides in this area, in the defaulted area, and this defaulted area will let this area 0 to 1300FF. This area is for the mentioned bootloader program. And here this why there is 1406, this is for the address of the high interrupt, and this is for low interrupt for the entries. And so you can't program in this area, in this address area, because this will be occupied. So you need to write down this address area. And why there is 4? Because the code will be offset 1400. And if the code offset 1000, you will write down 1006 here, and here is 1016. Now I offsetted the code. Here you need to write down here code offset 1400. Since this offset is to fit with the program counters of the address bootloader. And except this, there is some more area need to be rewritten. Here bootloader, you go to header, you go to this bootloader program. Here in this program, I need to change this value. Original code is 1000. I make more memory for the bootloader by 400, so I write down 1400 here. Here is no use this two line. Anyway, I change it to add 400 more, and here originally 1016, and they are adjust to this value. And going back to the bootloader main program, here this main program here, if you don't change some area here, the code size will be large, and there is blinking LED for LED. If in my board I haven't installed for blinking LED, so I deleted the program here. Here I delete this statement. Anyway, I already deleted the program for the blinking LED here. Here is two program, how to link the two program together. There is a function here, loadable here. In the main program, there is function is loadable. You click here, and right click, and at the loadable project, choose here, and here you choose the non-shaded bootloader project here, then it will add to here. So the meaning is every time this IDE runs after the main program is debugged and built, it will go to the loading of the bootloader program together, the hex file, and then the two files are combined together, and they call it unified hex file. This bigger size file contains two small hex files to one, and this one hex file will be programmed into the microcontroller. So in the first step, I click here and then run this. After running this project will contain a bootloader hex file, and here it shows it is running successfully. Anyway, it also programmed into the MCU. There's no problem. Then after running it, I will go to main screen. I click here. Here is to run the main program. and also it will program all the things into the microcontroller. And it is now building is okay. And it's programmed. That's here. So I can test the program. First I hit the key switch number 1, number 2, number 3, 4, 5, 6, 7, 8, 9. And also I test the interrupt 0, the pins interrupt 0, and touch the 0 ray and the LED flip. This the program is okay, main program. And now I detach this stuff. And also here, I don't know if I do it in a correct sequence. I hit the power. And then test the LED again. 1, 2, 3 is normal, and also the interrupt pin also normal. And here the MCU already have the bootloader program and also the main program. The main program work well. And then I detach the power. Now I attach the USB cord into the computer, into the microcontroller board here. It lights up. And when doing the USB, 2 steps I need to do. One is to switch to operate this switch to ground, and then I go to the screen here. I say before the program is here. I double click here, so it's not yet detected here. It's not detected. I do it again here, insert it, and I need to slide this switch and also press the reset button here. 1, 2, 3. Now it is detected, and the next thing I will do is to show how to rewrite the MCU by loading another new program into it. Of course, I don't want to do anything on make change on the bootloader. First, I need to remove the. Actually, I already removed, and before I had added this here. I add this lower board project here. This time I only want to do the main program individually. I don't want to link it with the bootloader, so I remove this out. And in the main program, I already have this subroutine flash here. This time I want to make it activate. This is a program to flash the LED on the RA0 by time interval 215 milliseconds. So here I click on this main program and build it again, and during the building it will debug it. After debugged, it will output the hex code and build success now, and also loading complete, and here loader complete. This path shows the hex file was standard in this path, and the file name is production hex. Roll back here, and you can see this. I'm now using the free mode compiler, and back to the directory, and in this folder, and this path, this and this production here, the time is 1:49. Here is 1:49, so I search here. So one hex file here, 1:14. This hex file was produced, and in before there is a unified. Let's combine the hex file here. This is an array file. So all I need to do now is to import this hex file in here, and go to this directory and click on this one, and it was opened here, and click on this icon, program, and this program, and it's now doing this, and it's complete, and OK. So the new program loaded into the MCU, and it will flash this LED. I remove this USB, then I operate this standalone and attach the battery, and after I slide this switch and also press the reset button, then this is flash in time interval 125 milliseconds. You can see I test the LED lights up. And this is all for the implementation of the USB bootloader for PIC18F4550. If you like the video, please thumbs up and subscribe us. Thank you for your watching.